just need to remember that constraints means size. Let's look at the first option. It can be as large as it likes. So we're putting a constraint on how large it can be. So option A is true. Next option, where to place each item. As I said, constraints is all about size, but here we're talking about the layout, like where you're placing each item. But constraints has nothing to do with layout; it only has to do with size. So option B is false. How small can it be? Once again, we're putting a constraint on its size, so this option is true. The maximum width and height of the layout. So maximum width and height are just dimensions of size. So option D is true as well. Which of the following is not true about the layout modifier? Okay, option C is not true because we know that layout phase and drawing phase are completely separate phases. First the layout phase takes place, and then you move on to the drawing phase. And obviously, layout modifiers will be applied in the layout phase, so not in the drawing phase. So C is clearly not true. So answer C is right. Rendering a scrollable set of items as they become visible on the screen rather than all at once is the main concept behind lazy layouts. Actually, we had a similar question in the previous session. We came across lazy columns, right? If you want to define a column, you need to specify the exact number of elements that are present in the column. But when you don't know the exact number of elements, you can instead use a lazy column. So similarly, since all the items don't be visible on the screen at once, you can keep loading more and more items. Theoretically, you can load infinite number of items by using lazy layouts. True or false? Compose uses a single pass layout system. It's actually false. Theoretically, hypothetically, it tries to achieve a single pass layout system, but that's actually not possible because sometimes first it has to understand the size of the child, and then it has to pass again. So it ends up being a multi-pass layout system. Everything cannot happen in one go. This is the ideal scenario to have single pass, but practically that doesn't happen. To adjust an animation's fraction, which lets the animating value speed up and slow down, use. The answer is easing. Originally I thought stiffness because in the previous session we talked about spring animation, right? So spring animation means in the beginning phase of the animation, the component will accelerate, and in the final phase it will decelerate. So in a spring animation we use different stiffness to determine how quickly the animation happens. So I thought it would be stiffness, but the thing is they're not specifically talking about spring animation. They're talking about any animation with variable speed. So we have to choose easing. Stiffness is specific to spring animation, but it doesn't apply to all animations. Okay. In Compose, there is no way to update the UI after it's been drawn without changing state. That's true. Because if you want to update a UI, then you have to change the state of the UI. That's basically how Compose works. So without changing the state, you can't update the UI. The UI will stay the same. Which of the following is true about unidirectional data flow? First option. It's difficult to test state and the UI that displays an isolation. It's actually unidirectional data flow is supposed to make things simple. It doesn't improve the difficulty in any way. Option A is false. There's only one source of truth for the state of composable. So what does unidirectional data flow mean? All the data is coming from a single source. So the data will stay consistent throughout the app. Since all the data is coming from the same source, you won't find any conflicting data. So you're basically avoiding bugs. That's why you use unidirectional data flow. So option B is true. Not all state updates are immediately reflected in the UI. This option is irrelevant. Like UDF doesn't UDF doesn't play a role in the performance, so UDF has no effect on that. Let's check option D. It's less likely that you create bugs due to inconsistent states. Yes, that's the main reason for using UDF. If like just imagine if you get data from two different sources and they both send you different data, then obviously you run into bugs. To avoid that, you simply use UDF. So that's the main advantage of UDF. Compose has a special state tracking system in Compose has a special state tracking system in place that schedules recompositions for any composables that read a particular state. That's true. Recomposition means I already explained what composition is, right? First, you come up with all the UI components and you place them in a semantic tree based on their hierarchy. Recomposition means after you encounter any state changes, you have to come up with a new set of new composition. That's nothing but recomposition. When state changes, a recomposition is triggered to display the new data on the screen. Yes, that's true. I mean, depending on the scenario. Sometimes, let's say you click the button and the button turns from blue color to red color. It's not really displaying any new data, but you can also use it to display new data. Recompose just those composable functions that need to change. Yes, because when you click on a blue button and it turns to a red button, you don't have to update the whole screen, right? You just have to update the button. You can leave everything as it is. If you update every single UI component every time, it will reduce the performance of your app. So you certainly don't want to do that. Third option, recompose the entire UI. So that's exactly what you don't want to do. Finally, update the properties of a view. Updating the properties of a view is something you used to do with XML, but here we are using Jetpack Compose. Jetpack Compose only deals with the state changes. It has nothing to do with the view-based approach. So option D is irrelevant. State is always mutated inside the scope of a composable function. So when a state goes outside the state scope of composable function, a state change occurs, right? But if the state stays the same, or if the state stays in the scope of the composable function, then you won't find any state change. So this is false. It won't mutate unless it goes outside the scope of the composable function. They said inside. Instead, if they say outside, then we have to click on true. Store objects in the composition by using the dash composable function, which can be used to store both mutable and immutable objects. So for this, you use remember composable function. The nav controller component does which of the following? We had an entire pathway uh, that's dedicated to nav controller in the previous session. So if you have any doubts regarding this concept, then you have to go to the previous pathways. So it keeps track of the backstack. So I won't go deep into explaining what backstack is since I already did that in the previous session. Displays the current destination of the graph. No, it doesn't display any destination. It just takes you to a destination by using the backstack. Enables backstack manipulation, so you can modify the backstack however you wish by using the nav controller. And it navigates between destination states. That's true as well. That's the whole point of using nav controller. That's the purpose of nav controller, to navigate you between different destination states. So moving from one screen to another screen basically. Eighth question. A dash takes you directly to a specific destination within the app. Deep link. So route is supposed to help you navigate, but it doesn't necessarily take you to the destination. It will just tell you where each screen is. But deep link will directly take you to a destination. Like if you click on a link on a website, it will take you a different it will take you to a different web page, right? Similarly, if you click on a deep link, it will take you to a different destination within the app. We finished three pathways, we have two more. Let's finish them as well. So these last two pathways are quite small. True or false? In Compose, you can test a component in isolation. That's true. We discussed this in the previous session as well. You don't have to test each and every composable function within an app. You can just test certain composable functions that that you're that you're suspicious of. Like if you feel like a certain function has bugs in it, you can just test that function, and you don't have to test any other function. So this is true. Compose tests use a structure called the dash to look for elements on the screen and read their properties. For that, we use semantics tree. So we came across semantics tree in Unit 3, Pathway 1 in the previous session. So if you want more information regarding it, once you need to go through that code lab. On phones, an on-screen element that the user interacts with should have a width and height of at least 48 dp. This is the minimum requirement for width and height. dp means device independent pixels. So it's just a unit of measurement basically. It's a unit of size to measure on a screen. So any UI element cannot be smaller than 48 dp. Use dash to group together actions that relate to the same list item. For that you use custom actions. When evaluating your Compose app performance, it is very important to make sure you are running in release mode with R8 optimization enabled. So for the best performance, you need to run it in release mode. And R8 optimization should also improve the performance a little bit. So in the release mode, so when you want to release your app to the users, you want the app to have the best performance, right? So that the users don't have to go through any trouble. So that's why release mode will have the best performance. This is true. And an application is dash when deployed as debug. So unlike in release mode, in debug, you don't just have to emulate the app, but you also have to debug it. You have to look for bugs. So it's doing two things at the same time. So obviously the performance will reduce. So the app will run slower. So this is the last pathway. After you finish this pathway, your course is done. So this is about form factors. In each and every pathway, we come in each and every course, the final pathway is always about form factors. We need to make sure that our app functions well on different devices, basically. Window size class is determined by the entire physical screen, but multitasking or other segmentations. Okay, basically they're saying the window size for your app will be determined by the size of the entire physical screen, but that's not true because some of your physical screen is occupied by the notifications bar, and it can be occupied by other things as well, but we don't take that into consideration. For window size, whatever space we have left, we only take that into consideration, so not the physical screen but the space we have left on the screen. So this is false. The foldable state where a device is fully open or fully folded is called, that's called the normal posture. So basically a laptop, if it's completely closed or if it's completely open, then then it's called a normal posture. This is just a terminology. What is great for you for easy navigation and usability when you're using medium-sized devices? For that, we use navigation rail, right? We came across navigation rail in the previous paths as well. Basically, it's the rail that's present on the bottom of your app. So you have a bunch of buttons. They're laid in a horizontal way. Like you'll have a row of buttons in the bottom. By clicking on one of those buttons, you'll be taken to that particular screen. That's what navigation rail is. Like if you want, I can show you an image. So in this case, this is the this is the navigation rail. Most of the weight-related dependency changes will be in which of the following Compass libraries. So this is a question related to Wear OS. Wear OS is basically just an Android OS, but it's specifically designed for smartwatches. Let's go through the question again. Most of the Wear-related dependency changes will be in which of the following Compass libraries? They'll be in the foundation and material libraries. It's mentioned in the code labs. So the last question is, Wear OS is compressed of multiple surfaces that include which of the following? They include complication, tile, and notifications. So complication means like if you ever used a smartwatch, so the part which shows the time is nothing but the complication, and everything else that doesn't. No, sorry. Complication is the part of the screen that doesn't show the time. Like for example, the battery indicator. The battery indicator will be present on the screen, but it has nothing to do with time, right? That's called a complication. It's just a terminology. And next, tile. Tile means it's basically just a bunch of icons laid out on the screen. That's what tile is. Since they'll be laid out and they look like tiles, that's why it's called tile. Basically, just icons of each app. And you know what notification is? The notifications that are displayed on your screen. So these are the three surfaces that are included in Wear OS. Let's see. Okay, we got them right. So you have to finish this course by October 18th. Sorry, October 8th. That's the deadline. If you have any questions, you can type them in the chat box. So I'll wait for 1 minute. If you don't have any questions, then I'll end the session.